Hi, welcome to this video on the method for mathematical induction that only requires 3 steps. We're going to see this for all different types of induction that you expect to see in your course, whether it be A-level, IB, or a university course. And we're going to see how it can work for all these different types in detail. And I'm going to go through some examples in later videos. In this first video, we're going to actually see how mathematical induction works. This is important because it's going to help you formulate your proofs. If you don't know how it works, you don't know why mathematical induction works, you'll often get confused with some of the steps and why you do some of the steps. Whereas if you have a clear understanding on why it works, it becomes very logical. There's nothing to remember, and you'll be able to sort of formulate the proofs no matter what type it is, whether it be divisibility or a summation or a completely different topic later on in the future, because mathematical induction can be used to prove lots of things from lots of different disciplines. So let's have a look at the idea. So the idea is we're going to try form a domino effect. So we're going to assume that it works or something is true for n equals k. Usually we're going to have a statement that relies on n, and it's true for all n, where n is an integer. We're going to assume that it's true for some value of n called k. We're then going to use this assumption to prove that it's also true for n equals k plus 1. Now k plus 1 is the number after k. So what we've done is, by assuming it's true for k and showing it implies for k plus 1, we've said that whenever there is a number that's true for, it's going to be true for the number after that. But well, that also means it's true for the number after that. So say we've proved it was true for 1. It would then be true for 2. We've shown that whenever it's true for k, it's also true for the number after k. Well, in this case, k is 1. Well, now we've got k is 2, so it must be true for k plus 1, so 3. We get 4, 5, and we get this sort of infinite domino effect up to infinity. So really powerful technique. This is the whole idea. In some later videos, we're actually going to see where this method slightly differs, but if you're able to understand this process and why this works, you'll be able to adapt the method to suit that particular problem. Now, the one thing we haven't talked about yet is where does the domino start? And this is where we need to consider a base case. So the base case, this is like our first domino. So in the example above, our base case would be 1. This is the first domino. By knocking over 1, you knock over 2, 3, 4, 5, etc. But you have to knock over a domino for this domino effect to happen. There's no point knowing that the domino effect can happen if there's no dominoes knocked over. Now, I said there's a 3-step process. What is this going to be? Well, first, we're going to do the base case. Now, for examinations, base case is the easiest. It's 3 marks. Not 3 as in the number, but 3 as in very easy to get. We're going to be subbing in, say, n equals 1 or n equals 2, and just showing it works for that case. Our second step is we're going to assume that it's true for n equals k. And then our final step is we're going to consider n equals k plus 1 and look for a way to involve step 2. And this is really a big overview of the whole method for every single question you're ever going to encounter. In the next videos, we're actually going to go through these different topics within mathematical induction, and we're going to look at how to attempt them. I'm going to give you pretty much an algorithm, so a step-by-step process for each of these different topics. So when you get confronted with a question, you follow this algorithm. Thanks for watching, and I'll see you in the next video.